Choo-choo! On board, we are on lesson 1-8. Today is magnitude and direction of complex numbers. Say again?
When do I get to make a lesson?
You want to make a lesson?
I want to do that.
That would be awesome. If you make a lesson, I will totally give you extra credit for making a lesson. Because it takes me probably half an hour each night to make sure that you have the notes correctly, that I've gone through all of Khan Academy. I do the homework first. I model, okay, what do they need to know for vocab? What do they need to know for the information? Give them some good practice problems and do all this stuff.
Maybe on the easy lesson.
I'm guessing it's going to probably take you guys between an hour and a half to make what I make in half an hour.
Yeah, I don't have that much time.
But I can do it with you. If you want to make a lesson with me, like you come in after school and you're like, Mr. Sano, I'd like to teach a lesson. I'll work with you to make the lesson, and then you will teach it like I do. You're going to be up here with Mr. Sandel's laptop?
Can it be non-math?
No, it has to be a math lesson. All right, so is there a... Oh, yeah, so today's date is Wednesday, September 18th, 2019. Make sure your name and date are on your paper. All right, quiet raised hand with your card raised in your hand. What is the objective for today, Eva?
Find the magnitude and direction of complex numbers.
And then Stego automatically logs that you got 50 XP, and I don't even have to ask her. Perfect. We're on to some vocab. So we know what magnitude is. Like if you have a magnitude 9 earthquake, it's how big the earthquake is. But what does it mean when I talk about math? Does anyone know what magnitude means?
No.
Good. So we'll learn that then. What about direction? That's pretty easy, right?
Yeah.
That way. That way.
No, that way.
That way. It just means where you're going, right? So let's talk about the word absolute value. When I talk about math, when I'm in a math class, laptop shut, Chris. If I'm in a math class, absolute value means distance from, quiet raised hand, easy peasy XP, distance from, quiet raised hand, Andrea? 0. It is indeed 0. And I can take cards that are in already. Who did cards? Stego has her card from the warm-up.
Oh.
Did you give yourself 50 XP for the warm-up?
No.
You can do that now? I'm thinking of getting more XP for the warm-up because that's kind of harder than normal participation.
My card.
What did you do? Oh, is yours not printed out?
You finished it?
I handed out all the cards that I had, so I guess I didn't get it back yesterday.
I didn't get one.
I'll look for it, James, but I'll pretend. Okay, you can be Fiona for today because I have Fiona's. All right, and a synonym for absolute value is from the title. Which one would you guess? Is it one of those? Take a guess. Teflon.
No, I'm not raising my hand.
Oh. What is a synonym for absolute value? It's somewhere in the title, somewhere in the objective. A synonym for absolute value with a quiet raised hand. I'm looking for a card. Who has a card? Who has a card? Oh, James has a card.
Magnitude.
It is indeed magnitude.
Wait, how do you say that again? Say that word again?
Magnitude.
That one word.
Synonym.
I can't say that.
Oh yeah, it is hard. All right, so write down magnitude. Know that when I say magnitude, and James got his 50 XP, try again. Magnitude, I'm really talking about the distance from 0. I'm thinking of distance. All right, so let's talk about distance in terms of what it means graphically. I always love to think of things in terms of their pictures more than their numbers. It makes more sense to me. Maybe it makes more sense to you to do just pure algebra, but I like pictures. So 5 plus 2i, there it is. It lives right there. We all nod our heads. That's 5 plus 2i. You go real axis 5, 2 on the imaginary axis. I need to know the distance from 0. So you don't need a ruler. You can just do a rough sketch. What is the distance from 0? Draw that line. That line goes from 0, the origin, all the way over here. It's technically not the origin now that it's the complex plane. But there it is. That is the distance right there from 0. How do I find the length of that line? Is there a quiet raised hand that has an idea to somehow find the length of a diagonal line? We've done it before, but can you remember? Is there a card out there? I want to call in a card.
Oh, wait.
Is that your card? Didn't you turn it in?
No, that was Theta. And Eva.
Okay, Teflon.
Is it the average?
The average of what?
I don't know.
She gets 20 points for trying, but that's not quite right. I'll still take the card though. Someone else. Someone that has their card. Anyone has their card yet? Chris, go again.
Go again.
Do you have your card? Yeah, so you're going to go again because other people still have their cards, so you're going to go for the second time today, yeah?
Doesn't have the card in general.
Oh, that's right. So this is me taking your card. Whoop. All right. And tell us the answer. How do you find the length of the diagonal?
So you do that thing where you do like crossing it up, right?
Yes, exactly. So you do this thing where you go across and up. So Pythagorean Theorem. There it is. And the Pythagorean Theorem, Chris, states what? If this length is A and this length is B, how do I find C? What is the formula, Chris?
A squared plus B squared equals C squared.
There it is. Thank you, Chris. Woo! All right. So let's plug these numbers in. I know that I'm really going 5 across, so 5 is A. So it's going to be 5 squared, and then B is 2, so plus 2 squared, and I will find C squared. I don't want C squared, I want C, so let's do some math. 5 squared, shout it out.
25.
There it is. And then I'm going to add 2 squared, which is?
4.
What?
No, Chris. 25 plus 4 is 29. And then I need to find C. Quiet raise hand. What am I going to do to both sides? Is there a card out there? No card, no card. Oh, Geo, yeah. Square root both sides. Can you turn on your card, Geo? I'm going to square root both sides. Lazy guy. All right, so then my answer here is C is equal to the square root of 29. Bada bing, bada boom. There is my magnitude. My magnitude is the square root of 29. And that is roughly 5.3, I'm guessing. Let's just, a square root of 29. Oh, that was close. 5.4 would be a better estimation. There's the length. Everyone okay on finding the length? It's just Pythagorean theorem over and over and over again. It might be confusing when I tell you to find use Pythagorean theorem on a complex number, because a complex number is just a number.
Is this just revision or what?
It's kind of a review. You haven't done it before, but it's just using that same technique. When I told you back in geometry that you're going to be using Pythagorean theorem over and over and over again in all of your other math classes, here it is. Here's your evidence. I'm going to be using it over and over.
What's the hard part?
The hard part is down here with the trig.
Oh, sine, cosine, they're back again.
So if I have a real part and an imaginary part of my complex number, what did I really do? Is there someone that can generate a formula using A and B squares and square roots to find the length, the magnitude of a complex number? Okay, so A is 5, right?
Yeah.
B is 2, right?
Yeah.
Can someone replace this line right here? Actually, we want to square root it also. So almost the same line, but square rooted for doing A and B instead of 5 and 2.
Yeah.
Who can do that? Go for it, James.
Yeah, go for it.
So 5 changes to 5 changes to
5 changes into 5. A.
A. So I have A.
Plus.
No, right here. I have A.
Squared.
Give James a chance.
Oh, sorry. Now Chris will do
Okay, Chris, take over. A squared
Plus
plus.
B squared.
Good. And then what am I going to do to all this to get rid of this square up here for C?
Square root.
There it is. There's our formula. It's a fancy formula. Super hard. It's literally Pythagorean theorem.
Wait, what happened to the I though?
Question, Gio? Is there a sign language letter Q? Question, Gio, what's up?
Oh my gosh, I care.
The I we didn't care about. So again, this length right here in the
Yeah,
imaginary
it's
direction, I don't care that that was in the I direction. I just care that it was a length of 2. I kind of ignored the I, just the fact that this was a length of 2. So again, the question was, why did we put an I here? Shouldn't we have a 2 squared I squared?
Yes.
No, you shouldn't.
We're really talking about the distance that you're traveling here. So we don't really care the fact that you're going in this direction. We only care about the distance. So if we're ignoring direction, which is I in this way, real in this way, if we ignore the direction, it's just a length 2, just a length of B. That's the answer to the question. Hopefully we're okay. Give me a fist of 5. How well do you think you can find magnitude of complex numbers? That's half of the objective today. Give me a fist of 5. Teflon out and say your fist of 5. Fist of 5.
Question.
For what? Wait, what?
Gio, what are you at for a fist of 5? Question, it's like, and then pinching down.
Wait, you pinch
That
what?
was violence right there. And this is why we
Question, Chris, go.
No.
Yeah.
So if I were to use that formula, it'd give me the same answer.
It'll give you the same answer. Chris, you can't say shut up.
You know what I just said?
You guys can't be disrespecting him. He had the floor. He did have the floor, and you guys were interrupting him. He was asking a good mathematical question. Is the formula and the Pythagorean theorem that we use, are they the same thing? And the answer is yes. That was a good question, Chris. I will give you XP because it was a good question, and they're disrespecting you, but I will also deduct HP because you told them to shut up. Geo's was going to protect you anyway, so don't worry about it. And
Good job, Gio.
Geo, you got 150 XP. It's okay.
No.
I'm just going to give you the 50. Okay.
You know,
Let's come back here to example number 1.
Can I heal Gio?
No.
Show me, you can do it after the lesson. Show me, all of you by yourselves right now, show me that you can find the absolute value or the magnitude of -2 plus 3i. Show me now. Do it on your paper. Choo-choo, we're back. All right, so absolute value of -2 plus 3i. I need a quiet raised hand who can volunteer to do the entire problem. It's going to be a person with their card. Everyone has their card in. It's going to be Chris. Oh, wait, Eva, do you have your card?
No.
Okay. Chris, go for it.
Can I use this?
Yeah.
Wow.
All right, show us, Chris.
Alright.
Show us the way.
Wait, is it right though before I even started?
Yo, is that a hood?
Where's your pencil? Oh. Alright, so. Oh. Why does it always go all the way back up there?
It always tracks to the spot. The right side will always be the right side.
Alright, so. I had. Oh boy.
Okay.
Is that 3?
Be respectful. I don't want to deduct any more HP today if I can avoid it.
Yeah, gee, leave me alone. Alright. So that turns out to be. Ready?
Are you plugging into the formula right now, Chris?
Yes, that's the formula right there.
Okay.
You guys got it?
Makes sense.
Right, right.
Yeah, moving on.
So now it becomes 4 and then plus 9. Right. Right. And then your answer is bam.
But there's one tiny thing that if I were a strict teacher, I would take away points. Can anyone find it? You can find it too, Chris. It's something to do with how substitution works. Whenever you substitute, you always need these things that you forgot.
Oh.
Is there a quiet raised hand that knows this, Teflon? You can sit down, Chris. You did a good job. He got this 50 XP.
Would it be this 4 squared plus? I don't know.
His answer is right. This is correct. This is correct. I'm looking somewhere right here. If I was being very precise, this is incorrect work. James?
Equals C.
No, you don't need the C because he's just using the formula. Go for it, Teflon.
Wait, we don't have to put the I in, right?
No I, no. Chris?
Now can you tell us?
I'll tell you. Parentheses.
Oh.
Parentheses are needed because this one doesn't matter. 3 squared is the same thing as in parentheses 3 squared. But this is very important in terms of being technically correct, which I love being precise in mathematics. -2 squared is actually equal to -4. But if I do -2 quantity squared, that is equal to +4. Because of that guy on the wall. Look at him. His name is PEMDAS. PEMDAS states you first need to do parentheses. Parentheses first. I've done the parentheses first, and now I'm going to do the exponent. Exponent says 2, which means I'm going to square everything in here, which means it's -2 times -2. Negative times a negative is a... But if I do not have parentheses, if I skip down to exponent, I'm first going to do exponent. Ignore this negative sign. I'm going to do 2 squared, which is...
4.
And then I'm going to do m, which is multiplied by the negative. Negative times 4 is...
-4.
It matters if you have parentheses. But he did get the correct answer. All right. Moving on here to a review of trigonometry. So with a quiet raised hand, trigonometry can be used when there is a what? What is that shape down there?
Right triangle, right
With
triangle.
a quiet raised hand, please. Stego.
Right triangle.
There it is, right triangle.
Left triangle. It's obvious.
Not an incorrect triangle, but a right triangle. Definitely not a left triangle. Definitely a right triangle. All right. If you do not have a right triangle, you can kind of use trig if you know some cool like rule of sines and cosines. But generally speaking, your normal default trig values are when you have a right triangle. So we are going to have a right triangle because we've been making a right triangle like we have above. Okay, sine. Do you guys remember SOHCAHTOA?
No.
Okay, if this is,
Side, opposite.
you can write out SOHCAHTOA off to the side if you want. SOHCAHTOA. But that only helps if we remember what O, A, and H talk
I
about.
know.
So if this is my angle of reference, that's my perspective,
Opposite and hypotenuse.
then this bottom leg with a quiet raised hand is what? Chris.
Your opposite and hypotenuse. Wait, what?
You can get 20 XP for trying, but I'm going to go back to
What was
Eva.
your question? What was your question?
This bottom leg is what?
Adjacent.
It is the adjacent.
I still get 3 HP.
You still get your 20 XP, yes.
Or
That means that this leg over across from the angle of reference is Teflon. It is indeed the opposite.
What?
This leg over here is opposite. I wish I could somehow rotate my... Is it possible? I'm curious. Can I grab this and then rotate it?
yes, it is.
I don't think I can. Okay, I'm just going to leave it like that. And then, of course, the diagonal here has what name? Nice and easy, Chris. It is indeed the hypotenuse. Everyone gets their XP.
Yeah.
All right. So if we know those, then I need 3 more volunteers, 1 per trig function. Sine is what over what? Is there a quiet raised hand? Andrea. Write it out. Opposite. Over hypotenuse. All right. I'll let you write that down, write that down, write that down, write that down. And then you're thinking cosine. Using SOHCAHTOA, cosine is what? Stego?
Adjacent over hypotenuse.
Write it down. Adjacent over hypotenuse. And our final trig function, I guess, tangent. What ratio is that? Eva?
Opposite and adjacent.
It is indeed opposite over adjacent. All right. And the final thing that we need to review is how to solve for theta. That is kind of the crucial thing. How do I solve for theta? So let's assume I have this function, tangent of theta is equal to 1. What am I going to do to both sides to undo tangent? Do we remember how to undo a trig function? All right, I'll give us the answer. To undo a tangent, I take the arctangent. So there's 2 ways of writing arctangent. The quick way is doing tan to the negative 1 of this thing and tan to the negative 1 of this thing. I pronounce this thing as arctangent. You can also write it like this. You can also, instead of saying tan to the negative 1, that's the same thing as arctangent. I'm going to pause here so you can write that down. Make sure that you know that this thing is pronounced arctangent, but I'm going to show you what that looks like on a calculator. You're going to be using a calculator today. I'm going to wait until pencils stop. Pencils stop. Push it up to the top. Okay, I'm going over to a calculator now. So if I open this up and click on my calculator, desmos.com/scientific, let's type this in. If I type in arctan of 1 and hit enter, I get 45. If I type in tan to the power of negative 1 of 1, I also get 45. I can also come in here to the function and type in tan to the negative 1 of 1 and get 45. The key thing here is I am in degrees. Everyone take a look right here. This little button says DEG. That stands for degrees. If I want to do arctan of 1, but I need it in radians, which is half of your homework tonight. Half your homework is doing this in radians. Literally, it's a click of a button. It's now 0.785. So it's in radians versus degrees. It's a click of a button. Make sure you're rounding it correctly tonight. Radians and degrees. All right, so in the answer in degrees is 45 degrees. The answer in radians at the click of a button is 0.785. 0.785. You need to be comfortable with both degrees and radians tonight. You need to be comfortable clicking a button on your calculator.
I'm
I'm
confused.
not comfortable with that.
I don't know how to use it.
All right, so all we've done so far is we have talked about magnitude and we've reviewed trig. We have not yet talked about finding direction. But up to now, fists of 5, how are we following the lesson? Okay, good scores.
You have to.
All right, we are on the back then. Finding direction. We are finally doing the second part of our objective today. finding direction. We already did magnitude, now direction. So, the direction is always from the real axis. I assume that this is kind of my north, or this is my 0 degrees. Can everyone put a 0 over here by the real axis? This, in the positive real dimension, real direction, that is your 0. That means if I rotate up here to imaginary, that is now 90, and then 180, etc., etc. But you need to know that you start at 0. Are we all clear on that?
Yes.
I don't even know why I asked that question. It was a bad question. Anyway, from 0, make a line to -5 plus 2i. It can be a sketch line. It doesn't have to be straight. Try to make it as straight as possible, obviously. I need to know what is the angle that this makes with this real axis. What I'm writing in my notes and you're copying down is, what is this angle right here? That is my theta. I want to know what that angle is. That will be my direction. If you have an angle, or if you have a magnitude and direction, you can find any complex number. Magnitude and direction. So we're finally hitting direction.
What is that little circle thing with the thing?
Theta. This is pronounced, and I'll write it up here, theta. Theta, and it's up there behind you. It's a Greek letter. If you look at a fraternity or sorority and they have that symbol in the 3 letters that they have, you pronounce it theta. Theta. And capital theta looks like that up there. You can always check your Greek letters. It's kind of a useful thing to know Greek letters, because when you go to college, you'll be like, oh, did you go to A Phi O? And you're like, what letters are A Phi O? Omega is which one? Yeah, memorize your Greek letters. It helps in college. I promise. It does help. Because when someone says, go to A Phi O, you will know which one to look for. All right, anyway, coming back to non-college, actual high school math. Now that I have the angle that I'm looking for, I need to somehow make a right triangle. I need to somehow use trigonometry. Does anyone see a right triangle that we could use?
No.
Yes.
Oh,
Yes.
Eva, tell us where the right triangle is.
it's right there.
It is indeed right there. The key point here is always make your right triangle draw a leg to the real axis. This leg always, always, always needs to go to the real axis. Leg always goes to real axis. Do not make the triangle like this. Let me make an orange triangle. Do not make this orange triangle right here, because it'll work, but then I have to teach 2 different lessons.
Down.
It just changes our formula slightly. It just takes the reciprocal of the formula. It's fine. It's just it's a different formula. All right. So if you have that, I now need to find that angle. So let's first find. Let's call this theta 1, and this is theta 2. I want to find theta 2. I first need to find theta 1. Actually, I don't think we'll just immediately jump to theta 2. We don't even need to find theta 1.
My head hurts.
Want to look at my card?
Yes, can you go grab the stuff from the color printer and cut them up? All right, so, and be careful about how you cut it. You get 1 shot, and I put them right next to each other. All right, so our formula here is this. If I take the arc, I'm jumping steps. Okay, whatever. I'm going to give it to you because we're running low on time. This is the,
Don't give it to us.
okay, I'm going to make you work for it.
No!
What did Mr. Brown say?
What did he say? I don't know.
Did you
do
Because
homework
I
for Mr.
probably
Brown?
couldn't hear
Huh?
because somebody
Did you
was
do work for Mr. Brown?
Do I work for him?
This length right here, everyone agree that this length right here is 2. Can we all agree that?
Yes.
Write it down. It's 2. This length right here is 2. What is this length right here? It's a negative number.
Wait, can you slow down a little bit?
Negative 5. I now need to find this angle. Well, I know that this is that opposite or adjacent?
Opposite.
Shout it out. Is that, that's opposite, and this must be, which trig function am I using with opposite and adjacent?
Tangent.
Write it out. Tangent of my angle theta is equal to what over what?
This is too much.
2 over -5.
2 over -5. All we have done is we have created a trigonometric equation that says that the tangent of this angle should be 2 divided by -5. You are correct up to this point.
Is that theta? Is that parentheses?
Yes, it is theta.
Okay.
But now we need to solve for theta. So how do we solve for theta?
Okay, I couldn't find it.
Oh,
Maybe it didn't print out. I'll try again.
Ow.
Now we need to solve for theta. What am I going to do to both sides to solve for theta?
Multiply.
How do I undo tangent? Look at your previous side of the notes. How do I undo tangent? I take the
Opposite. Adjacent. Hypotenuse. The circle.
Tan.
I take the arctangent of both sides. Write it out.
Mr. Sabell. Oh my god. What a
God,
class
these
I
kids
have.
are freaking.
I know the best class.
I take the arctangent of both sides. And by doing that, it eliminates the tangent. Just like up above, the arctan and tangent cancel each other out, and I'm left with just theta. Down here, same thing. Arctangent and tangent cancel each other out, and I'm just left with theta is equal to exactly the arctangent of 2/5.
What?
Wait, so what's the point of doing all that if you didn't get the same answer?
No. Do you see the negative on the side?
Oh. That's kind of mean.
Oh, just kidding. There it is.
There it is.
Yeah. Look who's wrong.
He
Yeah.
just
No,
said
you
it.
were paying attention.
Wait, is that a teacher there?
It is a teacher.
Oh, it is?
Yeah, I
Oh.
like it.
Wow.
All right, and here's your formula.
How's that teacher there? She didn't find it. She said just positive. That's not finding it.
No,
This
but then
is-
you realize you forgot.
Whenever you are looking for your theta, you are doing arctan. In fact, I'm going to write it out like this. Arctangent of, well, what is 2? Is that the real or is that the imaginary?
Imaginary.
So that's the b
Oh my.
over a. But, so that seems easy so far. All you do is take the arctangent of b over a. It's a formula that you plug in over and over. It seems easy. Here's the problem. This angle, theta 2, this technically was all theta 2, theta 2, theta 2, theta 2, theta 2, theta 2. The problem with this is, let's see what happens. When I do arctangent, so if I do arctangent of 2 divided by -5, I get this, we'll keep it in degrees for now, -21.8. Does this theta 2 look like -21.8? No, you should be shouting out no.
You know.
No, it doesn't. The problem with tangent, whenever I plug into the formula, the problem is this is the same thing as arctangent of -2 over 5. It's the same answer. When you do arctangent, it does not know whether to spit out the one in the second quadrant or the fourth quadrant. By default, and this is kind of key here, guys, by default, arctangent always spits out answers, and you're going to add this to your notes, that are in the first and fourth quadrants. Tangent lands here.
You know, I like the first problem we did, but then you lost me when I was 10 -1 and stuff.
I'll do an example problem, 2 example problems so you don't get lost. The tangent will land somewhere in quadrant 1 or 4. So if we know that we started in quadrant 2, what do we have to do to it? Do you guys notice the relationship between this line?
Yes.
What are we going to add to it? How many degrees? What's the angle of a line?
180.
There it is, James, 50 xp. I'm going to add 150. So I've had -21. If I do answer, look, I'm going to type in AN as soon as I type in S. Answer, that's the last answer. And I add 180 to that. That is the actual answer, which is 158.19. I'm just going to say 158.2. If I add on 180 degrees, so this is, right now I'm following with the notes, theta 2 is equal to
Wait, where'd you get the 2 from?
-21.8. I just plugged in arctangent of 2 divided by -5. I now need to add on 180 degrees because I'm in the wrong quadrant. Because I know that tangent lands in quadrant 1 and 4, I know that my answer should be in quadrant 2. I have to add on 180 degrees to get my final answer, which is 158.2. 158.2. So, the other thing that you can add to your notes to help you remember, if your answer should be over here, remember to add 180 degrees if your answer should be over there. If it lands over here, then you're good. Like if the answer defaultly was out over here, then you don't have to add 180. But if you should be in quadrant 2 or 3, you need to add 180 degrees. I have boiled down this process. Ready? Here's the process boiled down.
How did you get 158?
Say again?
How did you get 158?
Nice little
158?
Imagine.
I plugged this into my calculator.
Imagine.
Let's come back up here.
Imagine.
Arctangent of 2 divided by -5, I plug that into my calculator and it spits out -21.8. But it's in the wrong quadrant, so I add 180. Done.
So you just added 180.
I added 180 because it's in the wrong quadrant. Boiled down. As easy as I can make it. Here I go. If you're looking for direction, always use arctangent b divided by a. Look at your b, look at your a, plug them in. You get a number. Now, that's step 1. Step 2, check if it's in the right quadrant. If it's in the wrong quadrant, add 180. Done. It's 2 steps. Plug into the formula and check that you're in the right quadrant. If it's in the wrong quadrant, you're going to add 180. There's 2 steps. Plug into the formula, check that you're in the right quadrant. Plug into the formula, check that you're in the right quadrant. Let's try it. So, example number 2. First of all, -5 plus 3i. Let's do a quick little sketch. Which quadrant are we in? Are we in top right, top left, bottom right? Where are we?
Bottom right. Left.
I'm right about there. So we know that at the very end, what are we going to... We're going to have to add 180 degrees because it lives right down here. Exactly. All right, so now let's plug into the formula. So theta is going to equal arctangent of what divided by what?
-5 over
Careful. B divided by A.
-3 over -5.
Let's do that. So I'm going to come back here. Arctan of, and it's going to be -3 divided by -5, and I get 30 we'll just call it 31.0. This is equal to 31.0 degrees.
Wait, is it always
But that's wrong, because Chris said we needed to do what, Chris?
add 180?
We need to add 180 degrees because it's in the wrong quadrant. And our final answer is, I can just go like this, answer plus 180, and it's 211. 211 degrees. Boom, bada boom, done.
Why was that one easier?
Well, I boiled down the process, so it's nice and easy now.
Oh, okay.
Let's try the process again. First, make a sketch.
That's not too big.
Make a sketch. Which quadrant are you in? 1, 2, 3, or 4?
I know.
Top right. Top right.
Where is it, James?
Right, top right.
There it is. Top right. Okay, are we going to need to add 180 at the very end?
No.
No. Okay, who can do the formula for me?
I got you. Ready? So it's 4. It's that.
Theta is equal
Theta
to
is equal to 10.
arctan.
4 over 2.
Okay, so I just have to do arctan of 2. Arctan of 2, which is 63.4. 0.4 degrees. Done, done, done. Make sure that you're in the correct mode, degrees versus radians. It's a click of a button. But aside from that, you're done. All right. Woo!